Tonight, somewhere in the world, a person is sleeping outdoors. No walls, no locks, no weapon within reach, just a body lying still, completely unconscious, for 7 or 8 straight hours. And somewhere nearby, a predator that could kill that person in seconds walks past without attacking. This happens more often than you would think. It has happened for millions of years, and the reason why is not what you expect. You probably assume predators avoid humans because humans are dangerous, armed, unpredictable, not worth the risk. But a sleeping human is not dangerous. A sleeping human cannot fight back, cannot run, cannot even see the threat coming. By every obvious measure, a sleeping human should be the easiest meal in the entire ecosystem. So why isn't it? The answer starts with something your ancestors did long before they had spears, long before they had fire, long before they had anything resembling a weapon. They slept in groups. Anthropologist David Samson, who studies the evolution of sleep, has spent years researching how early humans and their ancestors solved the problem of nighttime vulnerability. His research, along with work on contemporary hunter-gatherer populations, points to a strategy that predates almost everything else humans figured out: strength in numbers. Not the strength of any individual body, but the mathematical strength of many bodies clustered together, watching, listening, ready to wake. In 2017, researchers studying the Hadza, a hunter-gatherer population in Tanzania, made a striking discovery. Using small monitoring devices, they tracked the sleep patterns of an entire community over 20 days. What they found was that the group was almost never fully asleep at the same time. Across those 20 days, every single member of the group was asleep simultaneously for a total of only 18 minutes. 18 minutes out of nearly 500 hours. This is called the sentinel hypothesis, and it describes something remarkable. Within a sleeping group, individuals naturally stagger their sleep cycles. Some people are early sleepers, some are night owls, some wake easily at small sounds. Without any conscious coordination, without anyone assigning a watch schedule, the group ends up with someone awake or close to waking at almost every moment of the night. A predator approaching a sleeping group is not approaching a collection of unconscious targets. It is approaching a system, a biological alarm network built from variation in human chronotypes that almost guarantees detection. Think about what this means from the predator's perspective. Survival for any predator depends on minimizing risk while maximizing the chance of a successful kill. A solitary human sleeping alone in the open is, in pure predatory terms, a reasonable target. But a human sleeping inside a group of 20 or 30 other humans is something else entirely. The math changes completely. The predator is no longer calculating the risk of attacking one vulnerable body. It is calculating the risk of attacking a group that contains, statistically, multiple sets of open eyes at any given moment. And predators are not stupid. Evolution does not reward predators who repeatedly walk into ambushes. Over countless generations, the predators who survived and reproduced were the ones who learned, whether through instinct or experience, that approaching a human group at night carried a cost that rarely matched the reward. Then there is fire. The controlled use of fire appears in the archaeological record at least 1 million years ago. Researcher Richard Wrangham at Harvard University has argued that fire did more than cook food. It transformed the nighttime landscape for early humans. A fire is bright. It is loud, in the way crackling and popping carries through silence. It produces smoke with a chemical signature that many animals are evolutionarily wired to associate with danger. Because in the natural world, fire usually means a landscape is actively burning and should be avoided. For a predator, a campfire surrounded by sleeping humans is not an invitation. It is a warning sign, written in a language older than language itself. There is also the question of scent. Predators rely heavily on smell to assess risk, and the smell of a human group, especially one that has been cooking meat over fire for generations, carries information. It signals the presence of a coordinated, tool-using, fire-controlling species. Many large predators, including lions and tigers in regions where humans have lived for tens of thousands of years, show measurable avoidance behavior around human scent, even when no human is visible. This avoidance is not learned individually. In some cases, researchers believe it has become partially instinctual, embedded into the behavior of species that evolved alongside increasingly dangerous dangerous human groups. This raises an important point about how predator avoidance actually works. It is rarely about any single trait. It is the combination, a group, a fire, a history of unpredictable, coordinated, sometimes violent retaliation. Predators that test a human camp and survive an encounter learn quickly. Predators that test a human camp and do not survive are removed from the gene pool, taking their willingness to test human camps with them. Over enough generations, this creates something close to inherited caution, a wariness that does not require each individual predator to learn the lesson firsthand. But none of this means predators never attack sleeping humans. They do, in specific and predictable circumstances. The danger increases dramatically when a human is alone, away from fire, away from the group, in territory where the local predator population has not had extensive negative experiences with humans. Crocodile attacks near rivers, leopard attacks on isolated sleepers in parts of India and Africa, and documented cases of large carnivores entering camps during long droughts when normal prey is scarce, all reveal the boundary conditions. The protection is not magic. It is statistical, conditional, and built entirely on the foundation of numbers, fire, and accumulated fear. There is something else worth examining here, something that goes beyond the predators themselves, the architecture of vulnerability that sleep creates, and how deeply that vulnerability shaped human social evolution. Sleep is not a passive state. It is, from an evolutionary standpoint, an extraordinarily risky one. An animal that is asleep cannot flee. It cannot fight effectively. Its senses are dulled. Its reaction time is slowed. And for roughly a third of its life, every single human who has ever lived has voluntarily entered this state of near total helplessness. Why would evolution allow this? Why would a trait this dangerous persist across millions of years of natural selection that should, in theory, punish vulnerability? The answer researchers have converged on is that the benefits of sleep, memory consolidation, immune function, tissue repair, must have outweighed the predation risk only because something else was simultaneously reducing that risk. Sleep and social grouping likely evolved together, each making the other possible. A solitary primate sleeping alone on open ground would have been selected against ruthlessly. A primate that slept within a vigilant, fire-using, numerically substantial group could afford the luxury of deep, restorative sleep precisely because the group itself was doing the work of staying alert. This is sometimes called the social sleep hypothesis, and it reframes the entire relationship between humans and nighttime predation. You are not safe despite sleeping deeply. You are able to sleep deeply because, for nearly the entire history of your species, something or someone nearby was making sure you could afford to. There is also a behavioral signature worth noting in how predators approach unfamiliar or risky prey in general, something biologists call neophobia, the fear of the unfamiliar. Most predators, even apex predators, are deeply conservative animals. They do not test new prey types casually because a failed attack costs energy, risks injury, and sometimes risks death. A human campsite, with its fire, its noise, its unfamiliar smells, and its cluster of bodies, presents a profile that does not match the typical successful hunt. Predators generalize from experience and from inherited behavioral tendencies, and the generalization that is formed around human groups across thousands of generations and countless individual encounters leans heavily toward avoidance. This pattern is not unique to humans. Many social mammals exhibit similar sleep distribution strategies, but few have taken it as far as humans did. Meerkats post sentries above ground while the rest of the colony rests below. Ducks on open water keep specific individuals positioned at the edge of the flock with one eye literally remaining functional during sleep, a phenomenon called unihemispheric sleep, where half the brain rests while the other half stays alert to danger. Baboon troops cluster near cliff faces and trees, using terrain itself as a layer of passive protection while group vigilance handles the rest. Humans, lacking claws, lacking speed, lacking the ability to retreat into trees as effectively as their ancestors once did, leaned almost entirely on the combination of numbers, fire, and staggered wakefulness to fill the gap that their physical limitations created. This dependence on the group may explain something else about human psychology that persists today. The deep, almost irrational discomfort many people feel sleeping completely alone in an unfamiliar place, especially outdoors. Camping alone in true wilderness silence often produces produces a specific kind of unease that has little to do with rational risk assessment, since statistically, in most modern environments, the danger is close to zero. That unease is plausibly a holdover, a signal from a very old part of the nervous system that has not yet caught up with the fact that the predators which once mattered are, in most parts of the world, gone, fenced out, or hunted into retreat. The peace you feel falling asleep at night, in your bed, behind your walls, is an inherited peace. It is built on hundreds of thousands of years during which your ancestors survived the night specifically because they were never really alone in it. Someone nearby was always close to waking. A fire was usually burning. The predators in the area had, over generations, learned to treat that particular combination of smells, sounds, and light as something to avoid rather than something to test. You probably do not think about any of this before you fall asleep tonight. You do not consciously check for a fire. You do not consciously listen for the breathing of others nearby. But somewhere underneath your conscious mind, in the oldest layers of your nervous system, the calculation your ancestors made every single night for millions of years is still running quietly in the background. You sleep, mostly unafraid, not because you have grown safe, because something a very long time ago taught the predators that you were not.